Hi, welcome to my 100 days training plan for preparing yourself in GenAI area. It's a structured approach for learning GenAI. This will be definitely helpful for your learning path. Will provide information on various labs with problem statements and solutions. And you can prepare this material for your exam preparation and also really helpful for you for your interview as well as certification preparation. Let us get into the detail. This 100-day training program is structured it into 5 different phases. The phase 1 comprising of 20 days, where we will be covering about the basic foundation with respect to Python, mathematics, natural language processing basics. So the second phase, which starts between day 21 to 40, where you will be learning more on deep learning and transformers. This covers various topics which include neural networks, Python, something like PyTorch intro, details about LSTM, GPT, and at the end you will be provided a practice session with an assessment. Phase 3 starts with the 41st date and it will go up to 70 days, one of the longest phase in this training program. In this phase, you will learn about core concept about GenAI, right from LLMs to RAG to prompt engineering. You will be provided you will be provided information about large language model, and then we will move on to what is tokens, some basic information about prompts, what is hallucination. We will talk about vector DBs. We will speak about FAISS, FAISS, which is nothing but Facebook AI summary CH. We will cover Retrieval-Augmented Generation, that's called RAG, and we will execute a mini project using which we will try to do prompt optimization and cost optimization. We will discuss on the latency as well as catching of information using GenAI concept, and we will be learning open source LLMs. And finally, we end up with the evaluation and the practice with an assessment on phase 3. Phase 4, we are going to talk mainly on the agentic GenAI. We'll start with the AI agent. We will discuss about LangChain agents. We'll discuss about multi-agent concept. And we also discuss about orchestration, human in the loop, and end up by doing a mini project, practice, assessment, and feedback. Finally, in phase 5, we will talk about how to productize your application. How will you use MLOps, concepts behind Docker, APIs, and we will be doing a final project, whatever you have learned from phase 1 to phase 5. So that's a 100-day plan. There will be additional subtopics are all added in every phase as we go on learning this. In the succeeding slides, we will be discussing more on what is phase 1 is comprising of and the related videos. As I mentioned in the succeeding slides, let's take phase 1. This is what phase 1 is all about. And we will cover all these topics in 20 days time. You are not going to spend hours together on learning this. You can take break as and when required. But please make sure that you follow the topics regularly to make sure that your learning is intact. If you look here, we will start with the Python basics. There is an already a learning cycle which is there as part of my channel, where you can learn Python basics. Here we will learn about the syntax, variables, data types, operators, loops, and conditional statement with specific examples. Then we will move on to Python functions. Here we'll concentrate more on reusable blocks of your code that perform specific tasks that will helpful to make your code more modular. Then we will get into OOPS concept, object-oriented programming concept, where we'll discuss about classes, object inheritance, encapsulation, polymorphism, and others. And we'll get into NumPy. It's a Python library for fast numerical computing using multidimensional arrays and mathematical functions. And then we will move on to pandas, which will be helpful for you for data analytics using data frames, for data manipulation, data cleaning, and the exploration of the data. We will be having a separated topic for data cleansing or data cleaning. It's a kind of a process to identify and correct the missing, duplicate, or inconsistent or invalid data from a large data model. Then we'll see how to use Python visualization. It's a kind of a graphical representation of data using charts, plots, and dashboards. Then we will move on to statistics. Here we will cover the science of collecting the data, analyzing the data, interpreting and presenting the data for decision making. And next comes the probability. We will study some mathematical model that will helpful for you on handling uncertainty and the likelihood of events occurring. Then again in mathematics, in day 10, we will cover about linear algebra. You know, linear algebra is a branch of mathematics dealing with vectors, matrix, and linear transformations. And this will be really useful topic when you are using machine learning. And then on the 11th day, we will be using NLP introduction, natural language processing introduction. You know, NLP is an AI field focused on enabling computers to understand and process human language. In due course, we will also discuss about tokenization. It's nothing but splitting the text into smaller units called tokens. It can be word or subword or characters. Then we will move on to text processing. That is preparing the raw text for analysis through cleaning, normalization, and transformation. And then we will move on to an excellent or interesting topic that's called TF-IDF, which is nothing but term frequency inverse document frequency. It's a technique for measuring the importance of a word in a document related to a collection of documents. We will see a real life example how to use TF-IDF. And then we will move on to word embeddings. In this area, we will be learning about numerical vector representation of words that capture semantic meaning and relationship. And then we will use cosine similarity. It's a way to measure the similarity between two vectors and vectors based upon the cosine of angle between them. And this is extensively used as part of vector database. We will be covering vector database in other phases. And finally, we end up doing a mini project, reviewing the project, and then do some practice. And then I may provide some practice sessions, and you can work on that. And if required, we can do some evaluation to ensure that the knowledge, whatever we have learned in phase one, is up to the mark with the help of some quiz, assignments, and project-based testing. That's all on the phase one. Well, let's see phase two related activities. Phase 2 spans across between 21 and 40 days, totally 20 days of effort. Here we will be doing deep learning, and we will do some work on transformers. So we'll start with neural networks, where we will learn about neural networks, machine learning model, and in association with what the human brain that learns patterns from the data. Next we will move on to the activation function. They are kind of a mathematical function that introduce non-linearity into neural networks to learn complex analysis. The third thing in the phase 2 is on the back propagation. This is an algorithm that update neural network weights by propagating errors backward through the network. And then we will move on to PyTorch, Python related stuff, where we will get introduction about PyTorch. I know it's a kind of an open source deep learning framework used for building and training the AI model. Then we will build neural networks by designing and implementing a neural network with layers, neurons, and training logic. Then we'll focus on bit advanced concept, that is a recurrent neural network. The architecture related on how RNN is designed to process sequential data by retaining previous information. And then on LSTM, that is a long short term memory. That's an acronym for LSTM. It's a kind of specialized RNN that effectively learn dependencies in sequence data. And then we will move on to attention. That's one of a nice topic, where it's a kind of a technique that enable model to focus on most relevant parts of the data that's being inputted. Then we will move on to the core concept called the transformers, where we will learn the architecture based upon attention mechanism, which is widely used in natural language processing as well as GenAI. Then we will focus on BET, bidirectional encoder representation from transformers. We'll see the introduction part and also do deep dive it into BET. Unless you need to edit, the data that's being passed to a model, we will be seeing about how transformers works, or we will be learning about transformer based language model which understand the context from both the direction of the text. That we will do more on the bet. And then we will move on to GPT. That's an easy one. Generative pre-trained transformer. That's an acronym for that. It's a transformer based language model designed for generating human like text. And then we will work on fine tuning. Here it's a kind of a process of adapting a pre-trained model to a specific task using domain specific data. Then we will see more example on text generation. I'd say, for example, automatically generating meaningful text using AI model with lots of examples. Then we will move on to summarization. Condensing a large text, maybe large volume of text in terms of PDF, having multiple number of page it into shorter version while preserving the key information. Such a thing we will be learning on summarization. And then another one is about the machine translation, how we automatically convert the text from one language to another using AI model with very simple examples. And then we will be doing some mini project, evaluate different model and work on model optimization techniques to improve model performance by minimizing the loss of function during training. And then we will work on a practice session and then work on an assessment section. In phase 3, which spans across from day number 41 to 70, we'll be seeing about GenAI core concept, which include the LLM introduction, and then we will get into tokens. Usually the tokens are nothing but small units of text, and how LLM process the input and output is based upon the tokens. And then we'll see on the prompt basics. It's a kind of providing instruction or context to guide the LLM to response. And then we will move on to different prompting techniques based upon the role that you play. It spans across the short prompting to step-by-step instruction, how to prepare it with lots of examples. And then we'll move on to chain of thoughts, kind of a chain of thought prompts. And then we will see what is hallucination effect, the response from any LLM which seems to be correct but totally incorrect. That's what we will be seeing under hallucination. And then we will move on to embeddings, how the the data, I mean the prompt as well as any input to the LLM, how it is represented in a numerical format and then put up there in the database. And then we will move on to vector database. It's a kind of database exclusively helpful for storing and retrieving the information using multidimensional embedding vectors. And we'll see about what are the different types of vector databases, which includes Facebook AI similarity CH, that's called FAISS. It's again an open source library. And then we will get into Retrieval-Augmented Generation, that's called RAG. This is where you can build a basic of RAG pipeline. And using RAG, we can generate end-to-end flow involving ingestion of the data, chunking, embedding, retrieval, and response generation. With proper UI and use cases, we'll see more on building how to build the RAG pipeline. And then we'll move on to document loaders. You can load large PDF, Word file, or web pages, it into your vector DB and use it for semantic search. And then we'll see the chunking techniques and we'll move on to retrieval, that is finding the most relevant document chunks based upon the user query. And then we will move on to how to combine the keyword CH and the vector CH for better retrieval. Then we will spend time on evaluation, that is measuring LLMs or RAG performance using metrics such as accuracy of the response, relevance of the response, as well as the faithfulness of the response to take a call or to take a decision on which LLM model is a better choice for your project. We will be doing a mini project and then we will see the prompt optimization techniques. And then we will move on to rules and controls to ensure safe, compliant, and reliable output using LLM, and that's called guardrails. And then we will see about how services that allow application to interact with LLM programmatically using APIs. And then when you use any LLM, some of them are free, some of them are all chargeable. and we'll see what are the various techniques to reduce the token usage, and then reduce how effectively we can use API and infrastructure expenses. Then we will move on to the latency related stuff that need to be taken care as part of your building an application. Then in order to save the response and reduce the time of interaction between LLM and your front end, what are the catching techniques are available that we will be seeing it on the 63rd day. And on 64th day, delivering LLM generated output incrementally as it is produced rather than waiting for competition, that we will see that. Next, we will get into an important topic called as multimodal. Here, AI system capable of producing multiple data types such as text, images, audio, and videos. How we are going to combine all them and then make it as a single, use case, that we will see that with a demo. And then we will pitch in and then see what are the all possible open source LLMs are readily available that can be used for your, use case. Then we'll see the fine tuning technique using which you can improve the task performance. Then we will get into evaluation, practice, and assessment. And with that, we will cover phase 3. And in phase 4, we will start with AI agent. We have covered LLMs, tools, and RAG model as part of phase 3. We will further use LLM, other tools, and the reasoning to automatically perform tasks to achieve our designated goal. We'll see what are the different types of agent types, and whether it is a reactive, deliberative, or goal-based, or learning kind of stuff. And then we'll see one of your prominent agent called LangChain agent. It is dynamically choose tools and action based upon user requests. We will see them using a real life example. And then we will get into tool calling. Here, it's a tool calling is a technique or ability of an LLM to invoke external APIs, databases, function, or services to complete task. Then we'll see what are the various mechanisms that allow agent to retain conversational context, facts, and a past interaction across sessions. That is, keeping everything in a memory, whether it's a short term or long term. And such techniques we will see that in the uh, day number 75. The next is an important stuff, that is reason plus act, that we call it as react. It's a framework where agents alternate between thinking as well as execution of the actions. Then we will get into multi-agent and advanced stuff. Here we will see the architecture with multiple AI agents which collaborate, communicate, and divide responsibility to solve complex problem. Then we will get into autogen framework. Then crew AI is another framework for organizing multiple AI agents into specialized crews that work together on workflows. On the 80th day, we will be working on planning, a kind of a task planner agent. Then we will move on to orchestration. That's on 81st day. We'll see how to coordinate agent, tool, and workflow and data flows to achieve an end-to-end task execution. Then we'll see about how to handle errors. Okay, any retry, failed operation, or incorrect output, how to handle that as part of our agent development. Then we will get into observability. It's a kind of a monitoring agent that behave, log, decision, tool usage, and then check for execution traces. Then let's see how human in the loop is useful for building the agent. Then we'll get into how to protect agents from threats such as prompt injection, data leakage, unauthorized access, and malicious tools. We'll do a mini project covering phase 4, and then we'll see more on the advanced agent. And again, we will look into more optimization technique with a practice and assessment. That's what we do as part of phase 4. And in phase 5, the last phase, where we have 10 days of work, where we will see more on MLOps introduction, and then we do model versioning and a brief introduction about Docker. And I'm not going to cover detailed Docker classes here because it's all available elsewhere. And then we'll see that how effectively we can use APIs, and then how to do deployment of this AI agent, and little introduction about deploying using CI/CD pipeline. And then we have learned about monitoring in phase 4. We'll be seeing about how to set it up with respect to production as well as MLOps, and then how to handle large load with a final project and a review of the work, whatever we have done. So this is what we are going to cover. So this 100-day program will really helpful for you to do quick learning about the AI, GenAI, and more on the building AI agents. So every chapter we will be having separate workout session with multiple examples, and the entire session will be managed with appropriate link to various days. So click on appropriate link, look into the relevant information what you are looking for, and I hope this will be definitely helpful for you for your day-to-day work with respect to AI, exam preparation, certification preparation, as well as facing interviews. Thank you. I hope this video helpful to you, and we'll see you in the next video. Bye.